Let's discuss the topic randomized algorithm and its types. Algorithm not only execute with the input that we are given, but also it generate a random number in between this. The algorithm will evaluate this random number and produce the output. This random number decide what to do next anywhere in its logic. This type of algorithms are called randomized algorithm. Typically, this randomness is used to reduce time complexity and space complexity in other standard algorithms. Next, we are going to discuss what are the advantages of randomized algorithms. For many problems, a randomized algorithm is the simplest and the fastest. Many NP hard or NP complete problems can be easily solvable. There are mainly two types of randomized algorithms: randomized Las Vegas algorithm and randomized Monte Carlo algorithm. First one is randomized Las Vegas algorithm. It always returns correct and optimal output, but we cannot predict its running time. That is, running time is not bounded. But in Monte Carlo algorithm, it is not necessary to get a correct output. May produce correct output with some probability. But Monte Carlo algorithm will terminate after a fixed number of steps. That is, its running time is deterministic. For example, we have an array and it contains n elements. In this array, half of the elements are A and the other half elements are B. It is in a shuffled manner. We have to just find an A in this array. That is the question. So we are going to discuss how we can execute this problem by using Las Vegas algorithm and Monte Carlo algorithm. This is the Las Vegas algorithm. It contains an argument as an array and its size is n. Then it has a loop. From there, it chooses a random index. It has n elements and so from there it chooses a random index. Then check whether the data in its index is A. If it is not A, it goes to next iteration and choose a next random index and checks whether it is A, and it continues this process until it encounters an A. This is Las Vegas algorithm. Next, here half of the elements are A, so anyway this algorithm succeeds by encountering A. So expected number of trials before success is 2. Therefore the time complexity is big of 1. Next is corresponding Monte Carlo algorithm. It contains an argument array A, size n, and k is a number, that is, we perform only k trials. Within this k trials, we should get an output. Then only it becomes success, else it will fail. Then I equal to 0. Then coming to the loop, there it will take a random index and take that element, it is first trial, then I. Then I is incremented, I equal to I plus 1. Then compare whether I equal to k and check whether it completed k trials or it encounters an I. If it happens any one of the condition, it will exit from the loop. Otherwise, it will go to the next iteration and choose next random index. Then next trial, it is incremented and check conditions and continue this process. It will exit from the loop only after encountering A or after reaching k number of trials. Suppose if the value of k is 3 and we didn't get the corresponding value after performing 3 trials, then it will exit from the loop by showing that A is not found. Actually the answer is wrong, but in this half of the elements are A and it is necessary to get a minimum A after minimum trials. After k iterations, the probability of finding an A is 1 minus half raised to k. This algorithm does not guarantee success, but the runtime is bounded. The number of iterations is always less than or equal to k. Therefore, time complexity is big O of k. Now we are going to see randomized quicksort algorithm. In this also, it contains argument as array A and starting index low and last index high. If low is greater than or equal to high, then exit from this algorithm. Otherwise, it will set a pivot element. Here it will choose the pivot element by using while loop. For that, choose uniformly at random a number from low to high. This randomly picked number be x. Then count elements in A from low to high that are smaller than A of x and place it in SC. Now count elements in A from low to high that are greater than A of x, then place it in GC. N is the total number of elements in that array. Then check whether the count of a smaller number is greater than or equal to n by 4. Like that, check whether count of greater number is also greater than or equal to n by 4. If both conditions become true, then x is the central pivot element. If it becomes false, it goes to next iteration and choose next random index as x and perform the same operation. When it will get a central pivot element, we will exit from step 2 and go to step 3. Then partition the array A. The first subarray has all the elements of A that are less than A of x, and the second subarray has all those that are greater than A of x. Suppose at present the position of A of x is in POS. Random quicksort will call 2 times recursively. First call is from low to position minus 1, that is pos minus 1, and second call is from pos plus 1 to high. So in step number 2 we can find a randomness. It randomly chooses the value of the pivot element. It is better to come the pivot element at the exact central position. In order to avoid the worst case situation, we are calculating a central pivot at step number 2. Next, it comes to time complexity. The time complexity of step number 2 is big O of n, and the worst case time complexity of randomized quicksort is big O of n log n. That's all. Thank you.